Hello, today we're going to talk about how to create a function in our program. We're going to start creating a new project and we're going to choose console application, and we're going to make a program to do loan calculations. So I'm going to name my program loan calculator. This wizard comes up, I click next, and remember I must uncheck security development lifecycle checks. This is to allow us to use the Scanf and the Printf functions. Click finish, and my program is created, directories are being built, and because this is a C++, my file is called loancalculator.cpp. We will not rename the file. However, I'm going to rename my main function to be just simply main. Now that I have my function, I must add some documentation, and I would like you to create at the top of the file. I want to know who you are, so put your name up there. Also, when did you do this? And a description. This program is used to calculate monthly payments of a loan. You can use the description given to you on your assignments. Because this is we're going to use exponents, I'm going to include a file, a library called math.h. So remember, # means directive, and I'm going to include a library, and I'm using the less than greater than signs as a tag to indicate this file is located in the standard common directory where the program was installed, Visual Studio was installed. If I use double quotes, it will indicate this file is the same directory where my loan calculator is. And if you notice here on the right, there is the standard afx.h. Alright, let's continue with our program. Okay, we're going to make our window slightly bigger. And in our main function, we need 4 sections. This will allow us to keep our program organized. Local variable means is only available and exists in between these 2 curly brackets. That's the scope of the variable, which we spoke about it before. So we need a variable to hold how many payments we're going to have. And we only make whole payments. We don't make half payments. However, the APR, the loan amount, and the monthly payment should allow for decimals. That's why we use the double type. Alright, now we're going to get some information from the user. As a reminder, to declare a variable, we declare variable type, then variable name, and at the end we use the semicolon to indicate end of instruction. The variable name must start with an underscore or a letter, followed by letters, numbers, or underscores. I use the prefix I to indicate this is an integer, which means is a 32-bit value, which does not allow for decimals, only whole numbers. Double allows decimal values, so I start with dbl and I declare my variables. since I have multiple variables of the same type, I separated them with commas, and at the end I used the semicolon. Okay, so before the user enters information, we must prompt the user what we expect. We're going to use the printf function. The printf function takes a string. A string is free text, and the free text is delimited with double quotes. That tells the compiler where the string begins and where it ends. We know it's a function, the printf, because it has parentheses. We ask the user to enter the loan amount first. After we prompt it, we must read from the user, and we're going to use the Scanf function. This also takes two parameters. The first one is the string, which indicates the format, and we say format with the percentage sign, and we're going to need a long float. Remember, we use long floats when we expect decimal values, even if the user enters a whole number. And we're going to store this in the loan amount. But since the function requires the address, not the value of the variable, we must use the and sign at the beginning of the variable name to say this is an address we're going to pass, not the value of that address. Now, we also need to prompt the user for the APR. We're going to use the printf, enter the annual percentage rate. And we're going to read a long float, because it's a decimal, and pass the variable where we want that value to be stored at. Lastly, we need to ask the user how many payments, also known as terms. And because the terms is not a double, it's a whole number, we're going to use digits. And we pass the number of payments. So if we want whole numbers, we use the D, and the variable we pass better be an integer. Now we got the three things we need for calculating the monthly payment. Let's talk about macros a little bit. Macro is a directive which replaces the macro with the value we assign. So we define a macro, and for instance, I'm going to call this percentage. I'm going to call this 100. So every time the computer sees the word PERC capital letters, it's going to replace it with the number 100. I'm going to use another one called months per year, and there are 12 months per year, and I define a second macro. We're going to need that to clean up the input from the user, because the user entered annual percentage rate, and we need to convert that to monthly percentage rate. And since the user can enter 6.5, we want to convert that into 0.065. Now that we have our values, our macros set, we're gonna clean our input. So we want to convert our 6.5 into 0.065 divided by, which we do by dividing the value entered by 100. CPU will see the equal sign as an assignment operator. It's going to evaluate the expression on the right side first in a CPU cycle. So it'll do 6.5 divided by 100. The result will be used in the next CPU cycle, which is 0.065, and it's going to see whatever variable is on the left side. At that point, it forgot that the original value came from the same variable, I was going to store it as the variable APR now is 0.065. Also, I want to convert the APR into monthly, and that is changing the value from 0.065 to divided by 12, which be 0.005 or something. Now, the formula to calculate monthly payment is given by this formula. Multiplying the loan amount times the periodic, or the APR, periodic interest rate, divided by 1 minus 1 plus the periodic interest rate raised to the negative terms, which is the number of payments. When we have a fraction, we gotta make sure we don't get a division by 0. The only thing that could make a division by 0 is 1 minus 1 here. And to make this 1 will be if the terms are 0, because any number raised to the power 0 is 1. So, because we have a fraction, I would like to create a variable called denominator, just to store the denominator part. The denominator says is 1 minus. We don't have a function, we didn't create a function to raise a power, but since we included our library called math.h, there's a function in there called POW, which stands power, and notice on the right it says it takes two doubles, x and y. X is the base, y is the exponent. So our base, and notice I use parentheses, and parentheses indicates a function. So our base is 1 plus our new APR after we have cleaned it, and the exponent is negative number of payments. Notice it takes a double and an integer here. And that's our denominator. Our monthly payment is simply the loan amount times the interest divided by our denominator. Now that we have our calculations done, let's display this to the user. I'm going to use the Printf function, and we're going to say the monthly payment will be $, and then I want to indicate this is a float with 2 decimal values, and it's a float. I'm going to replace that percentage .2f with the value of the variable monthly payment. Let's test this. I'm going to use Control F5 to run the program. The computer compiles it for me. And now, oh, I should have put a new line here. That's fine. So let's test $10,000 at 6.5%. And when I use 60 months, which is 5 years, and notice my monthly payment should be $195.66. If I put the new line, this press any key to continue will be in the next line. So all I have to do is add this, and I know my function works, my program works. Now we created our function, our calculations. It happens that we're going to need our calculations in more than one place. Copy pasting code is not a good idea if it's more than 1 or 2 lines. Since our calculations took all this, we should make a function. And to make a function, it's like declaring a variable. A variable is declared as variable type and then variable name. Similarly, a function is declared as function type or return type and function name. Same rules apply. First character should be a letter or an underscore, followed by letter, numbers, or underscores. To indicate this is a function, we also need to have parentheses. And to define the content of our function, or to the body of the function, we use opening and closing curly brackets, just like we did in our main. Now, because this function returns a double, like we had in our main, it returns an integer, we must have a return statement. It's a good practice that you also have a section for local variables. And we're going to have one which I'm going to call it return value. And at the end, I'm going to return the return value. We can also give it an initial value of 0. Now, our function needs 3 values to calculate the monthly payment. Remember that inside the parentheses we have our parameter list. The parameter list, if there's nothing inside the parentheses, is simply empty, but the list still exists. Since we have a section for local variables, we don't need one for input because the input is being passed to the function. How do we pass the input to a function? Well, inside the parentheses we create our parameter list, and this parameter list is like declaring local variables, which will have an initial value given by whatever object or program or function is calling our function. Let me explain. You declare a variable by using variable type and then variable name, just like that. If you have multiple parameters, you have to repeat the process. Even if you have multiple variables or parameters of the same type, you still need to declare a type per parameter, which in this case the parameters are treated as local variables. Now, our function must return this, the monthly payment. It's a good idea you do some documentation on this function. This function has a name. We call it call payment. As an input of periodic interest, number of payments, and present value or loan amount. The output, monthly payment based on input, and description, we can just simply utilize the same formula we had before. Like we had before, we also need, or we should have, a variable for the denominator. And the denominator is given by the formula of 1 minus 1 plus the periodic interest raised to the power negative number of payments. Then our return value is simply present value times the periodic interest divided by the denominator. Notice that I'm not paying attention to what the variable names were inside my main. These parameters are treated as local variables, which means they exist in memory as long as our code is being executed inside this beginning and ending curly bracket. Outside this scope, those variables do not exist. Now that we have created our method, we can utilize it. We can replace all this inside the calculation section to one line, which is monthly payment equal, we call our method. Our method expects parameters. As soon as I press the parentheses, an explanation comes up. And notice the first parameter has bold letters indicating what is expected first. Expects a double that represents the periodic interest. We have a variable type double called APR. So our APR must be converted first to periodic interest. We do it by dividing the value entered by the user divided by 1200 basically. Now notice in our method, first parameter is a double that represents the periodic interest. The second is an integer that represents the number of payments. That number of payments is being stored in our main by the variable I, number of payments. Next, and last is a double that represents the present value. Well, the present value is the loan amount. So we replace those 4 or 5 lines of code with one line by using this function called calcPayment. And notice they correlate, there are 3 parameters and they correlate to the parameters passed here. First parameter is periodic interest, second is the number of payments, and third is the present value. Now let's test our program using our function. Use Control F5 to run the program, and it's compiling. Notice that when we use the method here, calcPayment, it was declared right above. The computer reads top to bottom, so method already exists before it can use it. Now let's test, see if we get the same results. We do. Good. Now we have our method calcPayment at the top, and then we have to scroll down to find our main. The reason the calcPayment is first is because the computer must see it before it can use it. So it's being utilized here. In order to use it, the method definition must be already being seen, and that's why it's in the top. But if we have 20 functions, 100 functions, we have to scroll down to find our main. So it would be nice if we could put our methods down below. The problem with this approach is that when we run it, we will find an error because the method has not been found. The reason is we're trying to use it here, but it's not defined. It's actually defined down below. In order to tell the computer we of our method that you're gonna see declared down below, we must create something called prototypes. A prototype is simply the method header. The method header is this. So if we copy this over here, and instead of using open and close curly brackets, but we use an end of statement, it's just a method without the body, and that's a prototype, and that tells the computer this is the method declaration. You'll find the implementation way down below. Now if I run this, my program runs as normal. Now let's see what happens in memory when we run our program. We're going to start with our point of entry, which is the main function. I have created a spreadsheet here simulating our RAM with some memory addresses, and right now it's available for anything we need. So the first thing the operating system sees is a method called main. The type is an int, we call it main, and we don't know what's going to return because the return value is down below. The next line is this one that says int I number of payments. I don't know the value of that memory addresses, so I'm gonna say it's just garbage. Then I declare 3 doubles. One called APR, another called loan amount, and another one called monthly payment. Now, next line of code is this. Prompts the user, and then this function scanf passes the address of the loan amount. The computer doesn't care what we name the variables. The computer is going to do is replace the variable with the memory address. So the first scanf says loan amount, so it passes the address, in this example 1096, and it returns with the value entered. Then we repeat the process with the APR and the number of payments. So the APR in here is 6.5 and the number of payments is 60. Notice now we are at the calculation section and there's an equal sign. The computer is going to execute the right side of the equal sign. When it's done, it's going to save the results into the variable that's on the left side of the equal sign. What to emphasize now is when we invoke our method. When we invoke our method, an activation record is created that matches our my prototype. So this is a double method called count payment. We don't know what's going to return yet, but we know it takes 3 parameters: a double, an int, and a double. Remember also that our method, So these parameters, the three parameters we have in our method, are treated as local variables. And the values that these variables are assigned are whatever values we passed when we call our method. So the first parameter is the APR, which is that divided by 1200 actually. The second is the number of payments. So this value is copied here. Lastly, loan amount is copied into the present value. Notice that there are 2 or 3 different memory addresses that contains copies of the values. That's what's called pass by value. Now, inside our calc payment method, we declare 2 more variables. One is called return, which has initial value 0, and another double called denominator that has the value 1 minus will be 1 plus the rate, which is this, to the power negative number of payments. So that's the value of our denominator. Well, then the next line is this. The return is simply the present value times the interest, periodic interest, divided by the denominator. Now, after we calculated the double return, we have a return statement, the next line, which simply has an expression. In this case is the variable return. So what this keyword return does is, here where we have our method name, it's going to use a value, it's going to put a value here, whatever that expression says. That expression is simply the variable double return. It copies that value here. The next line is actually a curly bracket, the closing. That's the end of the method. At that point, any local variable plus any parameter passed is no longer needed and is returned to the operating system. And all is left is this method with an actual value. Once this curly bracket is reached, the closing one, it goes back to where the method was called from. And it was on the main, this line where it says calculations. Now this whole right side of the equal sign, the whole expression, now has a value. It's 195.66148. Then the computer sees the equal sign, and then on the left side of the equal sign there's a variable. And that variable is assigned that value that's on the right side. At that point, because this was a method, it's also released back to the operating system. The next line in here displays the results, and then the next line there's another return. The return, where's our function main, right here, has a 0 as a return, so it puts a 0 here. And at that point, the next line is our curly bracket, which means anything that was declared inside is released back to the operating system, and all is left is the main function with an exit code of 0. Now that we have finished our program, we have to turn it in as a homework. So notice our main function. There's where our method is. That's where our program is in the C source code. That's where I put it. So we're gonna close this, and we're gonna open Windows Explorer. Close this first, and let's go where that folder is in my C drive. Source code, and notice we have a folder called Loan Calculator. This is the root folder. I'm going to right click, select send to, where it says compressed zip folder, click OK, and now it created a zip file. The zip file is the one you're going to upload. Do not try to run the program from this zip file. It has to be decompressed first. Hope this helps. If you have any questions, please email me at the email address in your syllabus. Thank you.